Hello, this is Jim Webb. I'm working with Mike Meyers COMPTIA PowerPoint, Chapter 11, Building a PC. We're going to be doing this in class. It's going to be a lot of fun. So, we've already gone in and researched PCs, what it costs, etc. It's our first lab. So, we're going to learn how to do that. We'll learn how to install and upgrade Windows and the best post-installation practices. Now, we need to understand what a customer needs. For instance, you don't want to build a huge computer when all they need to do is check email. You need to build a computer that will fit their needs presently and in the near future. New hardware builds are probably the easiest. Here you're going to have to request the specs and the pricing for the equipment. They're pretty simple to do. It's a lot easier than upgrading. You'll also have to look at Windows features that each customer is going to need. Now, upgrade builds. This is when the customer wants to leverage their old hardware with new hardware. Sometimes that works, sometimes it doesn't. You have to make sure that the upgrades are compatible and that they will actually increase performance. The operating systems can be a problem, as can the hardware, particularly when you're starting to change technologies. Now, things that you need to build for: thick clients, thin clients, virtualization workstations, media workstations, etc. Know what you're going to be building. A thick client runs an operating system, modern, such as Windows 10, and is generally for productivity applications, or office automation, if you will. You need sufficient core hardware to support requirements of the typical office and home user. So they're going to have Office, Windows 10, very good capability for holding virtual meetings, etc. The thick client name doesn't mean it has to be big, it just has to have the capabilities. Most contemporary computers are powerful enough to build a thick client, or the components are. It doesn't take that long. Now, typical thick client. It's a box. In the box, we're going to put all the goodies, such as the CPU. Now, currently we're looking at multiple cores, probably running in the 4 gigahertz range. We want at least 16 gigabytes of RAM. Here, they're talking much less. Hard drives, they're talking just enough to get the system running. However, theoretically, you probably want 500 gig to a terabyte. You're going to want the latest graphics, and you're going to want internet access. Let's see. So we want 64-bit systems. 32-bit is obsolete. It limits you to 4 gigs of RAM. 64-bit will take you to much higher range. 8 gigabytes now is kind of a minimum, with a 500 gig hard disk being the smallest you want. You want the latest graphics driver and a network with at least 50 megabits per second download speed, and preferably faster. Ubuntu has lesser requirements, such as less core, less RAM, less hard disk space. Don't need quite the optics for it. It works better with a CD or DVD. Thick client, let's see. It's complete operating system with apps. Does not need the internet, but it's recommended. Now, thin client only does basic or minimal tasks. Basically, they're going to tie in with a server and let the server do the heavy lifting. It's cheaper, easier to deploy than a thick client. Think of point sale machines or small office workstations, even cash registers if you want. There you go. Only store the basic applications. Network is going to be important because you're going to have to be using those resources, and minimal hardware for the operating system. Now, virtualization. This is a big one, and we're going to be covering it in this course in many different aspects. It's a technology that allows you to run more than one operating system at a time on a single computer. Plus, since you're running in a virtual setting, it's a good place for experimentation. Virtualized servers can help us consolidate multiple machines into one box. You can save floor space, electricity, etc. Plus, you can experiment on them. For instance, our cybersecurity classes lets you do things that you wouldn't want to do on a normal computer or normal network. With workstations, virtualization is most often used to run a second operating system within the installed hard drive and operating system. For instance, we're going to be doing Ubuntu running on Windows. It should be a lot of fun. Now, for virtualization, you need good performance, lots of RAM, and a fast microprocessor. And in fact, most of the higher end things, it's all going to be the same. Lots of RAM, lots of hard disk space, fast processor, high speed internet. So a gaming PC, fast multi-core processor, lots of RAM, high-end video card. Now this is kind of interesting. Since so much of it is graphically oriented, you'll need a good video card that will have video RAM, and it's going to have its own processing unit on it. Okay, and a sound card is going to be optimal also. Graphic workstations, just like gaming, you're going to need lots of RAM, lots of high density graphics cards. Okay, yep, lots of storage. Audio editing, same thing. Fast multi-core CPU, lots of RAM, lots of storage space, plus a good audio interface. Microphones, instruments, usually they do these through the USB. There are some other things, such as the Sony Philips digital interface might come into work. And then control surfaces. This is where it gets interesting. A lot of the control surfaces can be done digitally. However, most people are used to the analog controls, so you may have a screen, a touch screen, that looks like the old analog controls. Just a little bit easier for the mind to comprehend. Let's see. So video editing combines the requirements for graphics workstation, audio workstation. Also, it has to have calibration for the monitors to make sure the color's right. And very powerful CPU is needed and lots of RAM. You're talking much more than the 16 gig. Also, high-speed, high-capacity hard drives. The video files are huge, particularly if you're dealing with 3D rendering, etc. And here you want a big graphics card, otherwise it'll tie up your CPU. So you're talking as much video RAM as you can get and high-speed GPU that's possible. Oh, custom keyboards are also a big plus. And then, how do we store all this? We have network attached storage devices. Here, centralized storage device that dishes out files and folders on demand. Okay, you place for media to stream to multiple devices, has specialized needs, take it beyond the thick client. 3 discrete functions: media streaming, file sharing, and print sharing. Most of the time now, it's going to be sharing files and media streaming. Media streaming can be used specialized software, okay, and requires very fast network connection. Since we're going to the gigabit range with fiber optics, that works great, and a lot of fault-tolerant storage. Can we say RAID? Now the software, you can easily turn Windows PC into a media streaming server. There we go. Some software you can download on that. The Windows Media Player and iTunes have features to share media for a local area network. Make sure not to violate copyrights. Here we go. There's some tools for that. And then hardware. Now, network attached storage. Okay, here the network attached storage hardware needs to apply primarily to the network speed and hard drive redundancy. So, for a large active server, you need to have a lot of RAM. Also, you're going to need wired gigabit Ethernet NIC card, all right? And you're going to need, at a minimum, 2 drives for at least RAID 1, which is a mirror drive, and as much as 4 drives for RAID 10. Now, it needs to share files, it needs to stream, You have to have RAID, and you need high-speed internet capability. All right. Installing and upgrading Windows can come from several sources. In the old days, we'd always do it from basically an optical drive. And before that, we had floppy disks, which was really taxing, both physically and emotionally. It took forever. And you basically boot the system into an installation environment. Okay. And let's see, so we can do it through DVD, we can do it through USBs, we can actually do it over the network or through a hidden partition on hard drives that have a factory installed. Remember, that was big with notebook computers. Somewhere in the middle of this, they have a second operating system. The disk that they send you simply gives you access to that. Okay. Now, the types of installation, first one's a clean installation. It's on an empty hard drive. Works great. An upgrade installation, you install the operating system on top of an earlier one. There can be some problems. You can lose things. A multi-boot installation, here you're going to have multiple versions of the operating systems. And then you can also do it through a remote network installation, which is very good for doing a number of similar computers. Now, clean installation wipes out the old installation, puts the new one on top of it. Okay. No problems for the old version to carry forward. The applications will have to be reinstalled, and you typically perform by setting the CMOS to boot from an optical drive, install a new system, and it overwrites the old one. Upgrade here, a little bit more challenging. It's installed on the same folder as the old operating systems. Okay, all the stuff is retained, but don't depend on that. Always back up first. There we go. When we install the operating system for the first time, we'll have two options, an upgrade or custom. If it's a fresh upgrade or new one, you'll want the custom. If you're upgrading over an existing system, you'll want the top version. Now, dual boot or multi-boot installations mean that you've got more than one operating system. What will happen then, you choose which one you want to have booted. For a multi-boot installation, it will basically use some tools that are easily available, and then it will let you choose which one you want to boot from. There we go, Windows 10, Windows 7, you could have Ubuntu, Linux, etc. Now, installing over a network, a remote network installation, it can be automated with special scripts created for an unintended installation. Now, in the old days, long time ago, at the end of the semester, we'd install brand new operating systems, basically wipe the disks, and my people would go like little monkeys from computer to computer, installing the new operating system, and then install the application software now. Now, what we do is we build one image the way we want, then we simply clear the old one, install a new image over the internet. We put them in what's called pre-installation environment, and there's some tools for that, and we install all the operating systems or all the images simultaneously. It saves a lot of time, a lot of work, plus you get the same quality product time after time. Here's a picture of it. Okay, so things that are important. End user license agreement. If you don't have the product key, there's a problem. All right. If it's not legit and you're doing it at work, you can be liable to suit. Now, the basic installation steps: turn on the computer, insert the operating system, follow the steps, okay, and make sure to have the product key available. Okay, when we're installing, you have a couple of options here. 32 or 64-bit Windows. Today's processors are 64-bit, so go with that option. 32-bit is yesterday's stuff. Set the language, time, keyboard. Also, make sure that you have the product key available and the Inliner's user agreement. You get a lot of trouble without those. There we go. You want your 32-bit installation. Okay. They'll record the settings. Okay. Install. Now with Windows 10, a lot of times you can pick your version. Professionally, the Pro or Pro N's pretty good. Then, do you want to do a custom or an upgrade? I like doing the custom, just a clean install. You can partition the hard drive and use what you want to or what you need to there. And let's see, the installation takes over the drives once it's been partitioned and selected. There we go. Here's your choice for custom, which is the clean or full install. There we go. Here, if you see multiples on a drive and you don't know what they are, it's a clean installation. Just delete them, redo them. And here, whether it's going to be set up for personal use or an organization. Now, when it's finished unpacking and installing itself, it's going to ask you how do you want to connect in terms of, is it a work group, organization, etc. You're going to be putting in username, passwords, etc. Okay. There we go. More on that in your networking class. Network installation takes automated step one further. It's ideal for deploying Windows to multiple workstations across the network without visiting them individually. You have to use what's called the pre-boot execution environment. It's a set of tools, okay, that enables a computer to boot from a network location. So basically, you're going to specify the boot order with network location first, and then see multiple installation images may be installed on a server, so you simply pick the one you want and install that. Now think about this. You've got different departments, different locations needing specialized software. You simply get an image that you need for that work group, if you will. Then you can install it on multiple machines over the network. Very clean way of doing it. Since you're taking time to get one of them perfect, it's usually a better installation. There we go. Here's some tools for setting up over the network. And then NetBoot. Here it gives you the tools for Macs. Don't do too much Macs, but it's similar in what you do. Now, other problems with installation. Okay, media errors, RAID not detected. Okay. May have to go back into the BIOS and make sure that everything is set up properly. Okay, let's see. No boot device present. Replace the startup disk or set the CMOS to look for the optical drive first. Graphical mode errors. Here, failure to detect hardware properly can be avoided by researching compatibility. Again, that's where your research is going to pay off big time. And let's see. Lockups during installation. It can be a problem with the disk drive, images, etc. Always good to have that good known disk. Then you can log what's going on to track progress. And during an installation, you'll get about 20 log files. They can be stored on the Windows directory. And if they're handy, you can call Microsoft and say, I'm having problems with this. They may have a known solution. Now, post-installation, a patch is a corrective program to fix a problem. These happen all the time. The old days, you could get a service pack with a bunch of these instead of having to do them all one at a time. The latest Windows updates immediately after Windows. At that point, it should be fairly simple. During installation, you may decide to go with default drivers that come with Windows. I do. I can upgrade as I add new devices. Then restoring user data files. After installation, you can restore backup user data. And this is where it's so important. You can use third-party backups software, Backup Restore Center, or things that have been copied to optical disks, USB, etc. Always install the essential software. And then migration. Oh, this is fun. It either goes really good or really bad. You're moving data and to new systems, and then you have to get rid of the old systems. Remember, if somebody gets hold of them, if it's proprietary, it can be used against you. Let's see, tools we have, user state migration tool. Let's see, Windows Easy Transfer. There's a bunch of them out there. Go. And what do you do with the old drives? Remove it. recycle it for use. However, if it's going to leave your building, as I was told by one gentleman in the Army, we take it, we microwave it, we degauss it, and we get a chipper, chip it into tiny pieces, and we bury it. You destroy the drive because people can pull the information off unless it is in a shape that cannot be read physically. There we go. Let's see. So sanitizing. Hard drive will still function once data has been destroyed. Low-level formatting writes ones and zeros to every location of the disk. Disk wiping utilizes old deleted data. Hasn't been overwritten yet, but I wouldn't count on it being gone. There we go. Here's a cleaner tool. And the recycle. Recycling paper and printer cartridges is good. Keeps them going to landfills. Some of them, computer parts, have hazardous chemicals. Check with the local authorities on where and how, or donate them to Goodwill. Take the hard drive out first. No installation is perfect, so we're going to have work forever. Be prepared to reinstall. If you have an OEM computer, it will probably have a recovery partition in the hard drive. Okay, with Windows 10, there are some privacy concerns. Logging in with a Microsoft account enables Windows to access personal information. Might consider using an old-style local user account, and you can have a privacy utility in the settings that will help you with that. Look for third-party stuff. Consider turning off these features. Let's see, let app use my advertising ID for experiences across my apps. Yeah, setting Microsoft information, it's not good. Letting websites provide locally relevant content, location, no. Don't want to get people to know you too well. You're at work.